Okay, guys, we're going to be talking about inverse trig function today. This is going to be page 68 in your notes packet. Okay, so inverse functions mean the opposite or the reverse operation. Okay, and when it comes to trig, we're going to be calling these also arc functions. All right, that's an alternate name for this. So if you ever hear the word inverse trig or arc function, those are both talking about the same thing. Okay. So we're going to start by leading on a few key points about functions. Okay, a graph that passes the vertical line test is considered to be a function. Okay, if your graph passes the horizontal line test, you're considered one-to-one, and your inverse is a function. Okay, if you fail the horizontal line test, you are many-to-one, which means you are not going to have an inverse that is a function. Right, inverse is not a function. All right. So some key points, right? Vertical line test tells you if you are a function. Horizontal line test tells you if the inverse is a function. Okay. Let's apply this to our trig graphs now, right? So sine and cosine, are these graphs functions? Okay, I'm hoping that you came up with yes, because they pass the vertical line test. All right. And can we tell if they are going to have inverses that are functions, right? So to do that, we will use the horizontal line test, again, I'm abbreviating, to determine that these functions' inverses are actually not going to be a function, okay? And that is because they are many-to-one, okay? Or because they repeat themselves, right? There are multiple times that the same y value happens, okay? If you want to see a little picture of it, we can jump down to the bottom. You can see if I drew a line through this graph, you see, hey, it is failing that horizontal line test, right? You're not going to be able to pass the horizontal line test like that, okay? All right. So let's continue talking about the sine and now its inverse arcsine. So we already determined arcsine wasn't a function. But we're not limited by that, okay? What we're going to do is we're going to do something called restricting the domain, okay? Which means I'm going to trim my graph down, and I'm going to go from right about right here to about right there, okay? And why pick those points? Because we're going to capture from -1 at the bottom all the way to the top at 1, okay? And that section will do that without repeating. That's the first section to do so, okay? So we're going to cut that domain from -pi/2 until pi/2 for sine. All right? So what this means is we chunked this graph, we cut it down, and that is actually this graph on the right. When I slice it down in the section that I've trimmed, that is going to be the restricted version of your graph. Okay? Now, by restricting, what we've done is we've made sine inverse into an actual function by trimming this down. All right? And this last bit is just telling you terminology-wise, remember that this term arcsine and this term sine inverse both mean the same thing, and you could literally use those words interchangeably. So if you hear the term arcsine or sine inverse, okay, they mean the same thing, all right? We call that the arcsine or the inverse sine. All right, so to create the graph of any kind of inverse, we always reflect across this line, y equals x. All right, and if you do so, basically your x and y points switch. The y becomes the x, and the x becomes the y, right? We can just flip the ordered pairs around, right? Remember, guys, we made a note here to remind you this is not the graph of cosecant. Cosecant is specifically the reciprocal, which means this is a flip, and arcsine is the inverse, which means it is the opposite, okay? And not opposite as though negative, but opposite as the reverse operation, okay? So the domain and range for these two is switched. Okay, so this is the reverse of what we had for sine. So the arc sine's domain goes from -1 to 1, and its range will go from -pi/2 to pi/2. Okay, so this was actually the reverse of sine's domain and range. We've switched them for arc sine. Okay, and you can see, hey, look, these points that they've pointed out are actually the switch of one another. The bottom line is sine x. The top one is arc sine or sine inverse. All right. Let's look at cosine. So cosine graph and its inverse, the arc cosine. Similar concept. We're trimming the graph down. Interval is a little different. 0 till pi. Okay. The reason that we're doing this is, again, we're going to go from 1 to -1. We're going to go all the way through the cycle without repeating ourselves. Okay. And if we wanted to sketch a graph, what I'm going to do is I'm going to go ahead and say, hey, there are a couple key points that I can use, some easy ones. Right here is 0, 1, pi/2, 0, and pi, -1. So if I switch the x's and y's, I'm going to find some new points for my cosine graph. So that's going to be 1, 0, 0, pi/2, and -1, pi. Okay. So this can be a little tricky to graph. Sometimes you may need some more information, but we're just going to try and sketch it out as best we can. So here is 1, 0, 0, pi/2, and -1 up all the way at pi. Okay. And so if you're not sure, this is actually like curving this way, and this one is curving this way. Like a little bit looking like a tangent graph, but it's actually just this blue section that's marked turns sideways. Okay, and that's what the arc cosine looks like. Remember, we could also write that as cosine inverse. Okay, like that. All right, so again, we've said all the details about this. We said, hey, these terms are interchangeable, arc and inverse. Okay, let's just state the domain and range really quickly. This is going to be from -1 to 1. Okay, and this is going to go from 0 until pi. Okay, you notice both of these domains have been the same. That's because the sine and cosine values always were between -1 and 1. Okay, those two values never changed. Okay, for tangents, I remember that we talked a little bit about domain, and we talked about how asymptotes break up our domain. We're not going to worry about that right now. We're just going to stick to a very, very simple definition where the domain starts from -pi/2 to pi/2. Okay, a very small period. Okay, and the range for that actually goes from -infinity until +infinity. Okay, because those had asymptotes. Okay, so for my inverse, what's going to happen is those two are actually just going to switch. Okay, so I'm going to have -pi/2 to pi/2 as my range, and my domain can be all real numbers or -infinity until +infinity. Okay, so those just switch for the functions, right? So we knew the domain and range for tangent. We went ahead and changed it to get the one for arc tangent. Okay, so we talk about sketching the graph real quick. If we wanted to, we can do that very simply. We know some of the points for tangent. We knew that we had -pi/2, and that was undefined. We had -pi/4, and that was -1. We had 0, 1. We had, 0, 0. We had pi/4 at +1, and then we had pi/2 at undefined. Okay, so again, this was the tangent values. And if I wanted to, we can inverse these by reversing them. So here's tangent inverse, or the arc tangent. Okay, and all we do is we switch these. So undefined, basically a point that doesn't exist. We've got -1 comma negative pi over 4, 0, 0, 1 comma pi over 4, and again undefined comma pi over 2. And undefined really means that they're going towards infinity. Okay, so this one is going towards, I'm just going to make a note, this is kind of like negative infinity, and this one is kind of like positive infinity. All right, so let's see if we can come up with something that looks like a graph for this. So I'm going to start with 0, 0, that midpoint, -1, negative pi over 4. Let's see if I can kind of estimate where that is. That's right there. We've got 1 pi over 4 as my counterpart to that. Okay, and as I approach infinity, my graph is going to approach these asymptotes. Okay, so initially these were vertical asymptotes. Now on the inverse, they are horizontal asymptotes. And so we can kind of play our connect the dots game. This one's going to swoosh this way, and this one will swoosh downwards. Okay, so filling that out gives me my tangent inverse graph. Okay, all right, let's summarize everything in one quick go right now. Okay, so I'm just going to fill in all the domains and ranges that we know. Okay, so initially, sine, cosine, and tangent were from negative infinity until infinity. Okay, all of these were the same. And what we did was we are ignoring the asymptotes on this. Okay, but they all had a range that was a little bit different, right? The cosine had a range from -1 to 1, bracketed. We have -1 to 1 for sine. And tangent actually had a special one. It had from negative infinity to positive infinity as well. Okay, so it was all real numbers. Now, these are going to be the reverse, but these are also restricted. So I'm just going to note the ones that are in red have restrictions. And restrictions just mean we've trimmed them down. So while, yes, we are switching the domain and range, these have been restricted, so they have a limited amount of space. Okay? So we're going to switch these, and this time my range is from -1 to 1, so this is my domain now. And my output, my ranges on here, are from -pi over 2 to pi over 2. Sorry about that, guys. That's actually the one for sine, not for cosine. So that range is actually from 0 until pi. This one is 0 to pi. Brackets again. Okay. Sine, on the other hand, is from -pi over 2 to pi over 2. And it again goes from -1 to 1 in my domain. And finally, tangents. Tangent has the -pi over 2 to pi over 2 brackets, and goes from negative infinity to positive infinity in the domain. Okay, so once again, guys, the ones in red are restricted, means they are limited in what they can do. Okay, now I just want to point out a practical application for this. Okay, what this means is that we are going to always have answers that fall within our domain and range. So if you ever have a question where you are not in the correct domain, you immediately know that that function is broken, right? So for example, cosine inverse of maybe 2, okay, does not exist. That is undefined because 2 is not in the correct domain. All right, that is not in restriction. Okay, so not in the restriction means that you get undefined.